Lesson 827, Are Angles Enough? Similar Triangles. In this lesson, we'll get to know whether two triangles are similar just by looking at their angle measures. All right, let's sum up what we did in our activity in class today. We're on page 88 in your workbook, and like we just said, we want to make sure we know whether two triangles are similar. Just by looking at their angle measures, not their size. Sides, not size. Know whether two triangles are similar just by looking at their angle measures, not their sides. In our last lesson, when we were looking at other kinds of polygons, the sides really mattered. We had to have a common scale factor. But in geometry, triangles defy a lot of rules. They're a magical shape, and to determine whether two triangles are similar, we just need to look at their angle measures. We don't need to look at their sides at all. So let's take a look at these two triangles, triangle ABC and triangle DEF. And to show that these two triangles are similar, all we have to do is show that there are two pairs of congruent corresponding angles. Congruent corresponding angles. All right, there's a lot to unpack here. So let's see if we have two pairs of congruent corresponding angles. I'm looking at angle A, that's 30 degrees, and its corresponding part over here is angle D, and I can see that's also 30 degrees. Well, that's good news. Let's look at angle C here. I know that's 45 degrees. The corresponding part in our larger triangle, this angle F, that's also 45 degrees. And according to this, all I need are two pair, like I have here, this pair of 30-degree angles and this pair of 45-degree angles. And that's enough. And the reason I don't need the third one is because if I know the two angles, I actually know the third one as well. In fact, let's go ahead and find it. We know that these angles have to add up to 180 degrees in a triangle. And we've done this before. To find this third angle, I just need to find the sum of the two that I know, 30 plus 45. And then the rest of it, this third angle has to be the remainder that I get from 180. So if I take 180 and subtract the sum that I found before, that gives me the third angle measure. So I know that this angle is 105 degrees, and this one's 30 and this one's 45. You know what, just for giggles, I'm going to go ahead and find this angle measure, angle B. Again, I know these two angle measures. Let me add them up. 45 plus 30, that's 75. And so this angle must be the difference between 180 and that sum. Oh my goodness, it's the same calculation, and it leads to the same angle measure. So that's why I don't need to see all three of the corresponding angles. If two of the corresponding angles are congruent, then the third one has to be 2. Okay. And I just want to make note of that. We only need 2 because the third has to add up to 180. The third will be the same as well. I'm going to say has to add to 180. And that should make sense from over here. Okay, so you'd think it would be there have to be 3 pairs of congruent corresponding angles, but really I only need 2 because if I have 2 of the angles, I really have all 3 of the angles, the corresponding pairs. All right, let's just do a little review of the kinds of translations, rotations, and reflections that we would need to do to fit this triangle, ABC, on top of triangle DEF. So triangle ABC and triangle DEF both have a 30-degree angle and a 45-degree angle. Let's go ahead and prove that they're similar using a series of transformations. Oops. So this down here is really just a transformation from triangle ABC to triangle DEF. So let's imagine, well, actually, let's get some patty paper. All right, I'm just going to draw my little triangle here. I'm just copying triangle ABC. And we're going to follow these directions down here and get this to fit right on top of this other one. We'll be able to do everything except dilate it. Okay, so the first thing it's suggesting that we do is translate A to D. Wow, that was a pretty loose description. They didn't tell us the direction or the distance or anything, but they said we're going to translate it. Oops, sorry, just translating. There. And then we're going to rotate it so the two 30-degree angles line up with each other. And that gets us to this figure right here. We translated this figure up into the left and then rotated it so that point A and point D sat right on top of each other. So once we've done that, all we have left to do is dilate this. Again, they're just giving a loose description of these transformations. So dilating this triangle ABC, and the center of dilation is where the two overlap. I'm going to call that A prime. We could call it D. They're the same point, say, or D. If we dilate it with that center and the appropriate scale factor, we're not sure exactly what that is, but it will move B prime to E. And that dilation will also move C prime to point F. And that shows that these two triangles are similar. All I had to do is some rigid transformations. I had to translate, rotate, and then dilate to get one figure to sit right on top of the other. Actually, for our summary question, we've already kind of written it down. Why are two congruent corresponding angles enough to be able to tell if two triangles are similar? I'm going to say C above. So, because up here we said we only need two, because the third's going to be the same as well, because that third one has to add up to 180 degrees. And we've shown that with our calculations over here. So, in summary, triangles are magical. Normally, with polygons, we have to pay attention to the side lengths as well. But with triangles, we can just determine whether they're similar looking at their angle measures. All right, enjoy the assignment tonight.